Today I will be presenting you our hybrid project, which is basically from solar and diesel generators in Humanitarian Hub in Malakal. So this Humanitarian Hub is located in Malakal or Upper Nile State of South Sudan. Humanitarian Hub has around 36 organizations and accommodations for more than 300 individuals. This facility is built on 84,000 square meters, and currently we are running some generators to fulfill our electricity needs, which is 810 kVA, 550 kVA, and we have also 275 and 165 kVA. On daily basis, we consume around 3,125 kilowatt hours of energy. On annual basis, we are consuming more than around 350,000 liters of diesel. So then we tried to move and convert our diesel power grid into the solar or hybrid. For this purpose, due to lack of funding, insecurity, and all other issues, because we are running the Humanitarian Hub on the cost recovery basis, we went for the power purchase agreement with one of the companies in private sector. So our hybrid power plant includes 704 kilowatt peak of solar arrays or PV modules, and then we have a battery bank of 1,600 kilowatt hours. Our battery bank is a very advanced technology from Tesla, and it will be producing on average 2,500 kilowatt hours a day. The balance of the electricity, which is 625 kilowatt hours, we will be still producing from the generator. Mainly these generators will be running after 4 a.m. to 8 a.m. or 9 a.m. where we will have again the solar sunshine, and then running back to the. So this is helping us on annual basis to reduce around 744 tons of carbon dioxide from the environment. Also, it will help us not to run the biggest generators in terms of economy, to run and keep to the smallest, because at the load at those hours when we will be running diesel generators will be minimum. So here you can see on this layout where we are putting the solar arrays. We have two directions, which is I have colored that one in red, and we have around 3 PV arrays around our facilities, which will be producing for us the necessary or the required energy. Next slide, please. So why we have selected solar or why we went for this energy or for this solution is because where we are living has no road access. It's a very remote location. The security is not good. And we have a lot of armed conflicts, robberies, and the corruption around our facilities or in the state where we are living. The quality of diesel is extremely low. It's very difficult to store the diesels, not only from the theft or the criminals, but also the storage facilities itself is a very high cost and very difficult to ship. We are shipping everything or supplying everything via air, so it's also difficult for us to have consistency in supply of diesel and spare parts, because sometimes we cannot have flights, cargo flights for us to supply our spare parts. So as it is shipping by air, the costs are also increasing quite rapidly, and also the flight also has effect on the pollution. Our generators, diesel generator also has pollution, and during the day when we are running the generators, even though it has soundproof canopy, but still it can produce noise and in the environment. So what are the basic advantage of our solar grid is that we will have reliability on and security for our power grid. We are reducing big amount of from production of carbon dioxide. We will have noise-free environments, at least during the working hours for our partners. We will be saving around 18% of the cost in terms of electricity production. We will bring stability into our supply system, electricity supply systems. We will also increase lifetime of our existing generators, so we will not need to change our generators quite often. We will also reduce the maintenance cost. We will have less dependency on diesel and also less dependency on the supply chain, and we will not face many problems with the logistical issues, which is one of the major factor in designing or implementing this project. So here is the business model, how we went. So as I told you before, this is power purchase agreement with one of the private sectors. So the capital cost for this project is around $5.4 million, which we do not invest. It will be invested by the private sector company. We will be paying only for the installation and the construction of the facilities for the solar system, which is around, and transportation, of course, which is around 300,000. Maintenance will be done by the supplier. We will be just paying on monthly basis. For the initial 3 years, we will have one rate, and then for third, fourth year up to 10 year, we will be reducing 19% on the monthly fee without losses or reducing in the terms of generation. So after 10 years, if this contract still continue, we will own the ownership of this project, or this equipment will turn into IOM. On annual basis, this is expected to produce 900,000 kilowatt hours. And what is the strong points about this is, as I told before, we are not investing, and this contract is open-ended, so it will be depending on the cost recovery. In case we cannot recover the amount that we are paying to the power supplying company, we may terminate contract anytime. So as I tell you, the first initial 3 years, we are reducing around 21% of the cost in terms of energy generation. From year 3 to year 10, we will save 33% of electricity generation cost. And from year 10 onward, we will be saving around 85%, which is quite massive. This is the so now we will go to another slide, which is the cost analysis. I cannot put the exact cost of the monthly fee and so on, because we have contractual obligations with our supplier that we will not dispose the monthly fee and so on. Here you can see currently we are spending around $70,000 in a month to produce electricity or to fulfill our electrical needs. And then when we have this hybrid project for the initial 3 years, we will be spending around $56,000, which is showing us that we are saving 18% in terms of generation. As I told you, after 3 years, we will be saving more, 33%, and this cost will reduce from $56,000 to $54,000 or $53,000, and after year 10 it will be quite massive saving, and then we may spend $10,000 or around those for generating the same amount of electricity. Another good point with this model is that in case we would like to relocate or move this project to another location, either in South Sudan or outside South Sudan, we will be liable just to pay the transportation and installation costs. So this is how it is managed. Now we will go to this model. So this will be a remote monitoring system using SCADA software, and it will be the maintenance will be done on quarter basis from the supplier, but day-to-day maintenance like cleaning, washing the solar panels, checking into the cleaning around, cutting the grass and so on will be done by IOM staff at the site. Thank you very much. I will be waiting for your question at the end of this session.